Hello, I thought I'd follow up on the last frequency counter project I've done with a short video on having a look at this. I'm going to do a tear down and repair on this. For those of you who have seen the last video, you would have known that this has actually been quite accurate and quite stable once it's warmed up, but it has a problem with being reliable. It sometimes cuts out and stops working. And actually, I'll try and show it now. It's currently running and measuring, and if I catch it right, you can see, there we go. So now it's no longer measuring frequency, it's just locked up. So there's an intermittent fault in there, and I wanted to have a look at that, and I think I can get it back. I know for all of you saying, oh, you shouldn't hit the instrument, it is old and it didn't cost me a whole fortune, but it's certainly with such a tap there shouldn't fail, so there's definitely something wrong with it. The other problem with this counter is these buttons. It's a very common fault on these, but basically while the buttons work, so I can increase the resolution by pressing that button, there's no tactile feel to it, and you actually have to press it quite hard, and it just feels very dead. And I know that Ian Johnson, if you have a look at his blog, has done a modification to this, just putting some replacing the switches. I did have a look around to see if I could find any switches that match the originals, but I can't. So I'm going to take this apart and see if I can do a similar modification to what Ian had done to his counter while I'm at it. So contents of the video coming up, basically quick teardown. We'll have a look inside, see what it's made up of, try and identify this intermittent fault, and then repair the front panel, hopefully put it all back together, back as a serviceable unit, and I'll attempt to calibrate it against the rubidium frequency standard that I've now got in my lab. Okay, so let's start with the tear down. I'll reposition the camera and we'll get going. Okay, so first things first, there's obviously board either side. I'm just looking at that. This top board looks like it's held in by two screws here, and also a bracket. I'm not sure if that's just the IEEE 488 port. I suspect it probably is. It's probably an optional expansion. Anyway, let's get that out and have a look. Okay, so that's the 488 board by the looks of it. It's a completely separate expansion. We'll have a look at the chips and stuff in a second. I just want to verify that the counter actually works without this board. I'm guessing it should do, but we'll find out and then we'll have a look. Okay, so it looks like that counter still works. Yeah, okay, so that's the 488 board. Okay, so a quick look at this 488 board. Nothing much to it. It's actually obviously very old school. Date codes, as far as I can get, 1998. Some of these chips, let's have a look at these date codes here. Date codes are not obvious. 1986, so somewhere between 86 and 90. It's obviously, I presume these have been around a long time. If that date is correct, this must have been an updated software version, 1998, 1999. Anyway, on there's nothing there. It's a 6805 based microcontroller, which is an old school 8-bit microcontroller. nice to see these. There's an Eeprom, which is obviously its firmware. There isn't any RAM chips, which well, I'm surprised to see, so I guess that microcontroller has some RAM inside. Actually, I'm just going to look at the datasheet and check that. Yep, just had a look at the datasheet. This has a massive 112 bytes of RAM, so very. They're obviously achieving a lot in not very much space here. This is probably quite simple to do. The other chip here is an MC68488, and again, looking at the the data sheet for that. It's a dedicated 6800 to the 488 interface bus chip, so it's a ready-made chip by Motorola. The rest is just discrete logic, 7400 discrete logic. The connectivity to the main board is on this 28-pin header, dip header, bit of ribbon cable. The other thing I noticed missing from here is there's no crystal or any kind of clock for this, so it's obviously taking the clock from the main board. So anyway, that's it. There's not much to it. It looks pretty straightforward, and I guess it is an option. The last time it was tested was in 1987. You can see it there. Okay, so let's have a look at the main board now. If I can see if I can zoom in here. I'll probably strip down this further. We'll have a look at the front panel in a second. But so first glance, what we've got here, starting at the top here, this is the firmware Eeprom. Again, that's where the expansion for the 488 interface plugs in. Again, same CPU, 6805. So whoever were the engineers on this thing, either that was their favourite microcontroller. It was one of the few available. These two, I don't really recognise the numbers. I couldn't pick out the numbers, and according to the schematic and the parts, these are both custom parts. But at a guess, just at a very high level, I would say that this is some kind of custom logic gluing it all together, and this has probably got the high-speed counters. You can see here these inductors. And this heavy ground planing, so I'm assuming around here is all the actual the digital counting part of the circuit. It's probably worth having a look in here. Not quite sure what we find in here, but so this can here is obviously part of the main board. Okay, it's got a couple of nice read relays by the looks of that. Some diode input protection, some resistors. I presume that's all to do with input load and protection. Another read relay there. A couple of trimmers, a couple of transistors. Not sure what that part is. Let's see if we can get a focus on it. It's an AD. $96878. You're going to find out what that is. Okay, that's a that AD96878 chip there is a high-speed comparator, 2.7 nanoseconds. So I guess that's the input shaping circuitry, probably self-biasing as we've seen before in other circuits. I think they had a similar thing in the that video amp that I used for the rubidium counter. So that looks like that input circuit. This thing here, again, it looks like I'm not sure I'll bother removing it. It looks like let me look on the front here. I know they make these counters with or without the this option. So this is the 2.6 gigahertz option, and by the looks of that looks like the option board for that. I'll probably take that out and we'll have a look. I'll just strip out the front panel. Nothing else of particular notable interest. I was having a look at the mains power, which comes in here, and the power switch here, which is here. So they've done a really nice job at building this. This is an aluminium plate. I'm not quite sure how that's fixed on there. Probably, possibly there. Anyway, we'll take that apart in a minute, but that's about it. There's not much here. The one thing I was curious about with this, because it was quite stable when it works, was what oscillator it's using, and I can see from here, this is the Cal frequency standard adjustment. Get that in focus there, and by the looks of it, it looks like a small oscillator block. Let's just have a look at that. I don't know if there's a part number on it. But it doesn't look like an oven controlled oscillator. So get some focus on that. Okay, so it's a 10 megahertz what looks like a temperature compensated oscillator. So this will be the equivalent to, on the Agilent counter that I was playing about with, the medium resolution, or sorry, the medium precision or medium stability, sorry, counter option for the HP. Okay, looks pretty straightforward. All right, so I think next thing I'll do is power this up and see if I can have a poke around and see if I can find the source of the intermittent problem. I'll just put this back to put it back together enough and do that. I'll come back on camera. Okay, so it's counting now. So I'm not sure. Oh, there we go. It's back again. That's stopped now. Yeah, that's locked up. I can hear the relay clicking as I press the board. It definitely seems to reset just by touching the board. I don't know if I can make it easy for you to see that, even just moving it around. So I'll just apply a bit of pressure there. That's okay now. Well, there we go. That's quite a lot of pressure. I wonder if the other thing that seems to be missing here is there doesn't seem to be any oscillator to run the microcontroller. So I'm assuming the CPU is actually clocked by the main 10 meg source. Let's just remove that and see what the effect is. Wouldn't really expect it to use its time base to actually run the microcontroller, but I guess this was sort of in the 1980s, so perhaps that's try and run it without it. Yeah, no, that's interesting. So that's the actual fault I often see when I first power it up, the lack of an oscillator. If that's the same cause, let's. Okay. Now the one thing I would say, well, that's interesting. So if you just, so there's basically 0.1 inch pin headers, 5 of them. Pull this out, and they're just plugging into this thing. And these are not, I wouldn't have thought these are going to be the most reliable connectors. Let's, so I'm just holding it in place. So if I just move this a little bit, yeah. Now that's me just moving it without putting too much pressure on it. Just moving it around. So that looks like it could be the problem. That'd be a nice easy fix if it is. Not exactly sure how I'm going to fix it though. Okay, I'm going to go and have a look a closer look at the this connector in detail, see if there's anything that can be done. Unfortunately, by the looks of it, the construction is, you can see here it's soldered in 2 rows, so I presume there's some kind of metal piece runs from front to back and then has some kind of pin receptacle. I'm just going to go have a look at that under the microscope and see if I can see anything clearer. I'm not sure that's going to be particularly repairable. Okay, I'll be back in a second. Okay, so just having a look at this, I really there's no real way of repairing this. So if those connectors are that dodgy, I'm not sure what I'm going to do. But what I'm going to do before I do anything else, because it could be that that's not the problem. There could just be a fault over in that board. So what I'm going to do is I'm going to use something like this, which I'm just going to plug in here. And I'm going to get the soldering iron out, and I'm going to solder that, hard solder that. So I'm moving, the idea here is that'll be soldered into the bottom. I'll solder it in from underneath, and that can be that oscillator can be out of the way. And assuming everything runs, then any movement around on the board here shouldn't actually cause the problem. If it does, then that's not likely to be the problem. So I'll just go and solder these up. There's no point in me having the video on, and then I'll come back. Okay, so I've just soldered that on there. I haven't paid too much attention to keeping it tidy, but there's basically 4 wires on the board. You can see there. That looks like a supply. A couple of grounds seems to be guarding what I would guess is the 10 megahertz signal, which is a trace that runs down here and goes into a cap. So that probably looks about right. Anyway, let's see if the the counter now actually still works after doing that to it. Okay, so I'll just leave the oscillator sitting on the back there. Okay, so that's good, that's still working. Let's just have a little press around here and see. Okay, so I think that's actually the problem. Now, what on earth I'm going to do with those connectors, I'm not entirely sure, but I'll come back to that. So, all right, so looks like I found the problem. That's actually a nice, easy fault. I'm kind of pleased about that because I actually really like this counter. I know it's old, and it's nowhere near as good as the HP. Now the HP's got the OCXO in it, but it is a really nice counter, and I would like to keep it and probably use it in the future. So I think what I'm going to do now, I'll worry about that later. I'm going to now look at the front panel here and see if we can sort that out. So I'll switch this off and strip it down a stage further. Okay, so from what I can see, the display board seems to be on these connectors here. That looks like it just removes, but having given that a tug, this seems to be fixed. There's 2 screws there, but looking at that board here seems to be soldered in, so I assume this has got to come off. Let's have a look at that. This connector is also soldered into the baseboard, so that looks like that nut has to come off. Let's just take this apart for a second. Okay, so this is got an SMA connector on it. Okay, so that's the front panel. I'm gonna have a go at taking this 2.6 gig option board out. It looks like it's held in with 4 screws here. Might as well take a look at that while the thing's in pieces. Okay, that's nice construction. That's a nice piece of milled aluminium plate or bar. Same connector. That's not a good sign. And not very much here. It's a lot of screws, but I think I'm going to take that apart and have a look in there. I'm curious to know now what the other side of that board looks like. Okay, so removed all those screws, a whole bunch of them, about 20 screws. These 2 are different. I'm not quite sure why they're like that with spacers, but what I'm going to do is just take a photograph of that so I know where they go back in. Otherwise it will cause a problem. May cause a problem. Can't quite see the point of those other two screws, other than that there is a sort of connector here, or that's a jumper. Maybe there's another option that goes on there. Yes, lots of RF goodness. So this looks very similar to the pre-scaler board that we put into the other counter. That looks like. Have a look here. So there's a whole bunch of input circuitry over here, all very discrete, probably FETs and stuff like that. This, I don't know what that is, some odd looking RF component, a filter of some sort maybe. And then there's 1, 2, 3, 4, 5 MMICs, and then this 8-pin chip here seems to have a, I don't know if you can see that, it's got a copper thing glued to it, or fixed to it. Yeah, thermally glued to it by the looks like. And that makes contact here. This acts as a heatsink. Yeah, very nice. Not bad for something that's built in the 80s. I've got these components here. LM339 7400, nothing special. MC 1011, which I think is an op amp. SP4730, not sure what that is. Let me just go and have a look. I couldn't find an SP4730. I could find an SP4740, which is a pre-scaler. So I presume that's a pre-scaler, and that's a pre-scaler. So it looks like there's two pre-scalers. Of course, in the 80s, they wouldn't have had the nice high density pre-scaler chips that we have access to nowadays. All right, so that's that. I'll put that back together, and then we'll get onto the front panel. I won't bother videoing this going back together. It's a bit boring, as you saw. Okay, so take a look at the front panel next. Looks like there's just a couple of screw here, and possibly these two spacers. Oh, okay. What have we got here? That's what the board looks like. Just some switches. Fairly old school LED driver, I think that is, ICM 7218A. Let me just go and have a look and see what that actually is. Okay, yeah, it's an 8x8 multiplex display driver, serial input. So, and there's two of them, and I thought, oh, that's strange because it's got one 8x8, but of course it's got all these LEDs here as well. Also, I noticed on these LEDs, they're big LEDs, and on the front panel, you can see that the actual red filter out, the aperture for that is actually quite small, and I guess this is just because of how old LEDs are made, but you can see every other LED has got a small black piece of sleeve on it, I guess just to stop light pollution making it across the LEDs. Anyway, there's nothing else on there. That chip there is a 74922, whatever that is, some kind of buffer, I guess. Actually, I'll go and check what that is as well. So I was completely wrong. It's actually a keyboard encoder. I've never seen one of those before. It's a CMOS keyboard encoder, 16-key keyboard encoder. So they seem to have done that in hardware, scanned the keyboard rather than software. Quite interesting. One other thing I noticed on this board was this LED right here. If you look at it, it's actually I don't know how clear it is on the camera, but that's actually wasn't originally in the design. It looks like it's been retrofitted or added for this model. Perhaps there's a variation on the models, because that maps to this overload output. That's how it mounts. So that overload LED for the 2.6 gigahertz option. So quite probably this when you fit the 2.6 gigahertz option, you probably change the front panel. Looks like, if you look at the construction of the front panel, this is a thin aluminium, brushed aluminium plate that's obviously glued onto this moulding, this cast moulding. So I guess you change the front panel to give you, this legend here, and it looks like in the factory they do that modification to add that LED on, which I guess was a bit of an afterthought on an early revision. Anyway, that's basically what the display board looks like. So next thing to do is look at these switches and see what we can do about them. Now, I don't know how easy this is going to be to see, but if you see if I can get some focus on here. So if you take this switch, you can see that I can pull it up and down. So that was originally its movement, but as you can see, if I just let go, they fall straight in. And what happens when you press them is they do make contact, and you do have to press them quite hard, but they're basically just not very good in that condition at all. So there must be something in there, whether that be spring metal or rubber or something inside that must have just broken or failed over time. So let's see if we can get one of these switches apart. I mean, they're all broken. The other thing is the cap type. You can see there it's a cross thing, which doesn't quite match the buttons that I've got. Anyway, let's have a look inside this and see if there's anything we can see. Okay, so I've just taken that button out. This is what we can see. So there's a bit of plastic. Oh, great. Yeah, very strange. So I think by the looks of it, I mean, I assume this was meant to be rubber, but this all just feels, I mean, it's brittle. And while I can get a little bit of play in it, it's basically brittle. And I'm not sure I'm going to be able to get a replacement for these buttons. I'm going to take another one of them apart and have a look. It's a very odd construction, maybe someone's had these apart before. It doesn't seem complete to me somehow. Oh, there we go. That looks slightly different. Yeah, so I'm guessing this was rubber, and in the past you can see that it does flex, but it is really, really hard. So that was probably softer rubber, and I guess it used to have some kind of spring or tactile action in there that's obviously now broken. Alright, let me see what switches I've got. Maybe we can fix it with something else. So I got these switches off eBay. I did ask Ian Johnson when he done his project where he got them from, knowing that I was going to do this, or the switches that he used, and these are the ones that he used. And the obvious problem with them is these buttons don't fit. So I'm not sure if I'll do the same as Ian done, which I think he drilled here, or try and do something else. Anyway, I'll have a start by making sure this is going to fit. So these are the switches, and so that doesn't look perfect, but it's not that far off. So I think what I'll do is take a photograph of this this board, make sure I don't get that blue switch in the wrong position, and then I'll get the soldering wick out and soldering iron. I'll remove all those switches and see if I can fit a bunch of these, or fit one of these at least, and see if I can figure out a way of dealing with these button tops. That's nice. There was some degree of serviceability in there, as I found myself designing PCBs. It's always good to have reasonable size holes. If you make the holes in your boards, this just as an aside, but if you make your holes in your boards too small, or small so the components just fit in, then actually desoldering them becomes a real nightmare. When you're desoldering stuff as well, you see that I used a big iron here. I tend to use quite a hot iron and just get them out quickly. Okay, so I've done a bit of playing about with the buttons here, and what I've done is I've cut the cross, you know, the aperture there for taking the cross the cross-shaped button, and I basically cut those out just using a Stanley knife. And then what I found is when they're cut out, the button is very, very close and it doesn't quite click. So when I clear it out, so I've used a bit of cable tie, just cut that to length on the button, so there's something that can get glued in, and the effect of that is the button then sits on there quite nicely and has a good tactile feel. And then lining that up on the actual board here, if you look, with the switch in place, not only I don't like the way those cables spread, those leads spread, because that's putting the switch under some stress. But when the button's on there, it's actually too low. If I get that lined up, I don't know how well you'll be able to see it, but it's basically about 1.5 millimeters too low. So what I've done is I've cut some of these, just 0.1 perf board, which serves two purposes. The first thing is it creates the space, so it's still even spread, so it's not wobbling around. But also, as you can see, it reduces the lead spread. So when that fits there, find it with the button in on top of it, the spacer. I'm going to have to glue all this together, obviously. That ends up, how well I'll see it, around about the same height as the original buttons, and that has quite a good tactile feel to that there. So that's what I'm going to do. I'm going to go through now and do all of those. No point in doing it on camera, it's all a bit boring. So I'll fit all those buttons and glue it all together. Okay, so here's the board with the buttons now fitted. You can see that I've put the spacer under each button, and that lines up quite nicely. You can see there. Okay, next thing, fit the actual buttons. Okay, so I fitted all the buttons, fitted the front panel back, and as you can see, nice tactile feel to all of the buttons. They're all working nicely. So I think that's okay. So next thing to look at now is the oscillator. Just put these out of the way. So this, there we go. This connector presents a real problem because it's not something that I've got. You can see that it's soldered both sides, a bit like a dip package. And but what I thought I would do is if I take this type of connector, as luck would have it, let me see if I can get this on camera. You can see that it's about the same size. So if I looking at this, I can probably trim this back and bend it over and create something that's almost the exact fit. So I think that's what I'll do, and replace this connector and see how we go. All right, I'll go away and do that. There's no point in videoing me cutting this up with a pair of cutters. Let's see how we get on. Okay, so let's there we go. Let's see if we can get focus on that. That's it there, and if you see, it's almost an identical fit. So that works out really well, and you can see there that the pins will get through the board. I'll only obviously catch it one side, or one set of pins. It'll be these ones here, and I'll probably just put a little bit of super glue underneath that. So let me go and solder that and fit that on, and then we can see put it all back together, then see if it works. Okay, so that's got its connector on it now. That looks like a pretty good fix. Hopefully that's going to fit in, and what I'm hoping here, that'll be a nice tight fit with it, which it feels really good. That feels like a good tight solid fit, so nice feel of a new connector. Let's put that in there. And back on with the front panel. I'm just going to rest that there. So I think this is the moment of truth. Hopefully I haven't broken it too irreversibly. Okay, here we go. Yeah, very nice. Okay, and what I need to do, I've actually just powered up that rubidium standard, so it's not going to be accurate, so ignore the actual readings here for a second. So we've got and you can see that's actually spot on. Okay, so that's working like a charm. So I think what I'm going to do now is just put it back together, and then perhaps by that time the rubidium frequency standard will warmed up, and then we can give it a quick cal, and I think that's it, job done. All right, back in a second. Okay, so it's all back together now. There you can see it's reading. It's reading off the rubidium standard. Got the lid and everything back on, and that's been sitting there for quite a while, so it's stabilised. What I'm going to try and do now is trim it, and that's a TCXO, and it's got a little variable capacitor. Unfortunately, of all the stuff I've got here in my little home lab here, the one thing I don't have is a plastic twiddling stick. There we go. So I'm going to have to use this and mess around a little bit. But just the point, when you're calibrating something like this, I wouldn't watch the display because it's not accurate enough. It's much better to use the scope. So I've got this is what I've got set up here. I've got the 10 megahertz reference coming in. I've got this going out to channel 1 and triggering on channel 1 on the scope, and then I've got the 10 megas reference out, which is the output from this oscillator in here, and that's going to channel 2 on the scope. So if I bring the camera up to the actual scope, let's get in there so you can see. So the goal is to get those two to stay still. As I said, that's the 10 meg reference coming from the rubidium standard. That's the output of the frequency counter's oscillator, and you can see that it's running slow. If it's travelling to the right here, it means the oscillator internally is running slow, and then the net result is we're getting a slightly higher reading on the frequency counter. So what I'm going to do now is just going to try and trim that in, see how close we can get it. This isn't a great oscillator, this TCXO that's in here, but once it is set, it is stable. The problem I've got though is I am trimming a cap with a metal screwdriver, and you're really not meant to do that. If I can get in there. So, and it is very, very delicate. I mean, I'm turning that a fraction of an inch. So that's running slightly fast. Now, if anything, my preference probably is to run it just a little bit faster. And it should be just a touch. That's pretty good. I'm not sure that's going to stay like that. There you go. It's running just a little bit faster. That's not bad. And then when we come down and actually have a look at the reading, what are we there? We're 2/10 of one cycle, 2/10 of a hertz, 3/10 of a hertz, and that is slightly creeping up. So it's slowing down ever so slightly. Just knock this up a resolution. So that is creeping up. Well, I'll just pause the camera and we'll see where that stabilises at. Okay, that's been sitting down probably for about an hour now, and it is drifting up and down a bit, so the oscillator isn't that good. I think probably even slight variations in room temperature are having an effect, because it sort of drifts up and drifts down. It's kind of settled there though, so it's about 31 hundredths of one cycle. above the 10 megahertz standard, so that's actually not that bad at all, really. I think it'll probably stay there, and if you have a look at the scope, you can see that there's still a little bit of movement there, but that's probably about as best as I can get it. I have tried trimming that out a couple of times, and I was just getting nowhere. So I think that's good enough. Probably when I get some time, I won't bother boring myself or anyone else for that matter with yet another frequency counter upgrade. But probably at some point I ought to stick a better oscillator in there, £20 or maybe $20 or something. I'll buy an oven controlled oscillator. It'll probably be a really good upgrade for that frequency counter. Anyway, I think for now, as far as the counter is concerned, I'd say that's now repaired. Can't make it go wrong by tapping it, which was the original problem. Okay, so that's it. I think I'm all done. I'll put this frequency counter away now. I think I'll give up on the frequency related stuff for a while. I am going to make some PCBs for the high stability option for the frequency counter, because quite a lot of people are asking about it, and also probably I'm going to relay out the track layout for the 3 gigahertz option, and maybe make some PCBs for that as well. I'll post a video or put something up once I've done that. Anyway, that's it for now. If you found that video in any way interesting, please give it a thumbs up, and I'll put the schematic for that counter on the associated blog page. You can get to the blog page for this video just at the link below here. And okay, so anyway, thanks very much for watching, and I'll catch you next time.